If you know the meaning of the terms you are using in mathematics or anywhere, then you will be able to use those terms effectively. I mean, you will be able to know when to use them and what term you need to use in a certain situation. Now in this video I'm going to demonstrate to you how important it is to know the definition of the terms you are using, because with this one formula, we are going to understand the concept simple interest, compound interest, and compound annual growth rate. And all these three concepts can be understood with this formula. Before going any further into this video, I strongly recommend you to watch the video on discount rate versus expected rate of return. I gave link in the description also. Please watch that and then come back to this video. In that video, we talked about how we got this formula. Now we are going to use this formula to understand simple interest, compound interest, and compound annual growth rate. Now, simple interest. Now, what is meant by simple interest? Say, for example, you gave some amount as a loan to some other person, and that amount what you gave will be known as principal. For giving that money as a loan, you will be expecting something in return from him, and that expectation, additional expectation than the principal, will be known as your interest. So here, this principal will be the money you gave today to some other person as a loan, and the rate of return you are expecting on that loan, which is known as interest. So simple interest is calculated only on the outstanding principal amount, and there will be no interest on the interest. We are not going to calculate any interest on the accumulated interest on the principal amount. You will be expecting interest only on the principal amount. You will not expect interest on the interest accumulated. Okay, let's understand this with an example here. Example is, suppose you gave 1 lakh as loan to your friend for a simple interest rate of 15% per annum for 5 years to be paid at the end of 5th year. Okay, so you gave 1 lakh loan to your friend at a simple interest rate of 15% per annum for 5 years to be paid at the end of the 5th year. I mean, interest and principal, everything will be paid on the 5th year. At the end of 5th year, your friend will give you the principal amount, whatever he took, I mean 1 lakh, plus the interest accumulated only at the end of the 5th year. Until then, you are not going to get anything in return. Okay, then what would be the total amount you would receive at the end of 5th year? Also calculate the interest component. So this is the question. Now we need to find out the amount your friend will give you in the future. I mean, at the end of the 5th year. In the future, at the end of 5th year, your friend will give you the 1 lakh he took. I mean, the principal amount, whatever he took, he will give you. In addition to this 1 lakh, he will give you interest. 1 lakh plus interest. Now, what is this interest? How much is the interest here? The interest percentage is 15% per annum for 5 years, right? So, interest will be calculated on the principal. For year 1, interest will be 1 lakh into 15%. The same way for year 2 also. 1 lakh into 15%. So, in the same way until 5th year, year 5 is equal to 1 lakh into 15%. So, here we are only charging interest on the outstanding principal. Okay, outstanding principal at all these year ends is 1 lakh only. Okay, so on all these 1 lakhs, we are charging 15%, and each year we got 15,000, 15,000, 15,000, like this until 5th year 15,000. We got 5 15,000. So here we can calculate future value. I mean, the amount you are going to receive at the end of 5th year including principal and interest, is that future value is equal to, you are going to get 1 lakh, right? 1 lakh. In addition to this 1 lakh, you are going to get interest. For each year, the interest is 15,000. 15,000 plus 15,000 plus 15,000, like this for 5 years. Okay, so it can be written as 1,000, 1 lakh plus 5 into 15,000. We are calculating 5 times, right? So 5 into 15,000. 15,000, how did we get this 15,000? 1 lakh into 15%. So 1 lakh plus 5 into 1 lakh into 15%. Now, the common factor among these two terms is 1 lakh. If we factor out this common term, then 1 lakh into 1 plus 5 into 0.15. 15% can be written as 0.15. 1 lakh into 1 plus 0.75. Okay. Now, what did we get at the end? This is the future value of the amount. Here 1 lakh can be represented as principal, and 1 is 1. 1 is the principal amount. It represents the principal amount, and 5 is the term of the loan. Okay. Term or time period of the loan, and 15% is the rate of interest. Now, to calculate the value you are going to get in the future, when you give loan as a simple interest, then the formula will be principal into 1 plus RT, the future value. This formula is to calculate the money you are going to receive in the future if you give that money as a loan on a simple interest. In the previous video, we got this formula, right? Present value into 1 plus R is equal to future value. Okay. Here, principal represents the present value of the money. What is meant by principal? Principal means the amount you gave today as loan to your friend. Okay. So the value of that money today represents the present value, and one represents the principal or present value. They both represent the same thing. And RT, what is meant by R into T? What does it represent? It represents the total number of years you lend that money and the rate of interest at which you gave the loan. Okay. So when you are multiplying these two, you will get the total interest, the total amount of interest you are going to charge on the principal. Here, R is the rate of return you are going to expect, that is interest rate, 15%, and T is the time period. Here in this example, 5. So total 75%. So you are expecting a return of 75% on the principal amount. Okay, total interest for the whole 5 years is 75%. Now in this example, the term of the loan is 5 years. Say for example, the term of the loan is 10 years. What happens? Then you will be expecting interest for 10 years. You will be expecting 15 into 10. Then you will be expecting 150% of return on the principal amount. Okay, so RT represents the rate of return you are going to expect on the whole period. When you are multiplying rate of return and term of the loan, then what you are doing is that essentially you are finding out the total rate of return you are going to expect from the loan. In this equation, this R represents the expected rate of return on the present value. Okay, so this expected rate of return and RT, they both represent the same thing, is equal to future value. Is here also future value. They also both represent the same thing. The answer here is that 1 lakh into 1.75, 1 lakh 75,000. 1 lakh into 1.5 into 0.15, 1.75, that is equal to 1 lakh 75,000. This is the total amount you are going to receive in the future, and the interest amount will be 1,75,000 includes interest. Now we need to remove that principal amount minus 1 lakh. 1 lakh is the principal, right? So the difference between these two will be my interest, total interest. So now we can say that future value is equal to principal into 1 plus RT. Now from this formula, you can find out answers to any number of questions. Say for example, if you know the future value, the amount you received in the future, and also you know the rate of interest and the term period, and you need to know the present value, then what you need to do? You need to keep this in one side, present value, I mean principal, and send this to the other side of the equation. Then what happens? P is equal to future value divided by 1 plus RT. In the same way, you can find out any one of these terms if you know the other terms. This is simple, right? That's why it is called simple interest. Now, compound interest. Now, what is meant by compound interest? Compound interest is that we will be calculating interest on the accumulated interest also. In simple interest, we calculate interest only on the outstanding principal amount. In compound interest, we will be calculating interest on the accumulated interest also, principal plus accumulated interest also. See here, interest is converted into principal periodically as agreed, and the interest for the subsequent period after conversion will be calculated both on the original principal and the converted interest. At each agreed period, at each interval, we will be converting the interest, whatever the accumulated interest, we will be converting that interest into the principal amount, and then for the subsequent period, we will be calculating interest on both the principal and also the interest amount, converted interest amount. When we are calculating interest in this way, then it will be known as compound interest. Okay, here interest will be calculated on interest, interest on interest. Let's understand this concept with an example, compound interest. We'll take the same example, but let's change that example to include compound interest in the place of simple interest. Suppose you gave 1 lakh as loan to your friend for a compounded interest rate of 15% per annum for 5 years to be paid at the end of the 5th year. Then what would be the total amount you would receive at the end of the 5th year? Also calculate the interest component. So here the interest will be compounded annually for 5 years. Let's calculate year by year. So here for the first year, the value will be 1 lakh plus 1 lakh into 15%. That will be 1 lakh. The common factor in these two terms is 1 lakh. So we will factor out 1 lakh, then we will get 1 plus 0.15. So the value will be 1 lakh into 1.15, that is equal to 1 lakh 15,000. So at the end of the year, the total interest and principal will be 1 lakh 15,000. So for the first year, we will be calculating interest on 1 lakh. And in the second year, we will be calculating interest on 1 lakh 15,000. Okay. So second year, principal will be 1 lakh 15,000 into 1 plus 0.15. Okay. So 1 lakh 15,000 into 1.15. That is equal to 1 lakh 32,250. In the same way for the third year also, we will be calculating interest on this 1 lakh 32,000. Now here if you observe properly, let's remove all these terms. First of all, here if you remove all this, if you observe properly here, this term is used to calculate the value at the end of first year. Okay, this term is used to calculate the value at the end of second year. Now what this 1 lakh is that 1 lakh represents the principal amount, that is the value of the money you gave today to your friend as a loan. In the future, that value will be increased by 15% at the end of first year. Okay, so 1 lakh into 1.015 will be 1 lakh into 1.15. You will get an answer of 1 lakh 15,000. So this 1 lakh 15,000 will be taken as the principal amount at the start of the second year. While calculating compound interest, the value at the end of the first year will be taken as the principal amount for the second year. Now this 1 lakh 15,000 will be my second year closing value. Okay, so this 1 lakh 15,000 can also be written as 1 lakh into 1.015. So in my second year, the term will be 1 lakh into 1 plus 0.15 into 1 plus 0.15. So this can also be written as 1 lakh into 1 plus 0.15 square. Okay, if you remember the previous video, in the previous video we derived an equation, right? What is that equation? Future value is equal to present value into 1 plus r power n. Here in this example, 1 lakh is the principal amount you gave to your friend, can be represented as present value. So here you are expecting a return of 0.15, that is 15% on the principal amount. Okay, so in this equation, r represents the expected rate of return, right? So you are in both the cases you are expecting a return of 0.15, and also this r represents the expected rate of return. Okay, now power, if you continue in this example, if you continue for 3 and 4 and 5 in the so on until n number of years, you will get the formula as 1 lakh into 1 plus 0.15 power n. If you want to test that theory, please go ahead and do for until 10 years at least, if you want to get proper idea about the concept. This n represents the number of years. Now here 2 represents the second year. For first year, here the power is 1, and for the second year, here the power is 2. In the same way, for third year power will be 3 and fourth year power will be 4, and so on for until n. And this whole thing is the value at the end of second year, right? That is, in future, from the start of the loan period, at the end of the second year, in future, the value at the end of second year is this much. So future value is equal to present value plus r power n. Okay, so you can calculate compound interest rate like this. Okay, this is the same equation we derived in the previous example also. Here present value, in the previous example we used the term present value. Here we are using principal. In the previous video we were using expected rate of return. In here we are using interest rate. Here only the name of the terms has changed, but its essence, its meaning has not changed. That's why the formula is same in both the cases. Now you can use this formula to calculate the future value when you are using compounded interest rate. Okay, I mean when you are converting the interest into principal periodically. In our example, we have compounded the interest annually. So what if we have compounded semi-annually? I mean, what if we have compounded every 6 months? Then in our example, the per annum interest rate is 15%, right? So for each year we will be compounding 2 times. Okay, now what happens to our formula is PV into 1 plus R divided by 2 times, right? 2 power n into 2 is equal to future value. That's it. So however many times we are compounding in a specific year, we just need to present value into 1 plus r divided by t into nt. So in compound interest, if you observe properly, what's happening here is that in this example, in the same example, let's say that at the end of first year, I gave you 1 lakh, right? For 15% interest. So at the end of first year, the interest will be 15,000. If you gave that 15,000 to me at the end of first year, then what I would be able to do is that I would be able to give that 15,000 to some other person as a loan and get another 15% on that 15,000 also. So at the end of first year, I will be having two loans there. I would have given two loans. That is 1 lakh to you and another 15,000 to some other person. Okay. So in the second year, at the end of the second year, I would get interest from two persons. That is 1 lakh from you and 15,000 you gave at the end of first year. You gave 15,000 as interest to me, right? So that person will again give me 15% interest on that 15,000 also. So I would be getting interest on both 1 lakh and also 15,000. So here, if you have not given me 15,000 at the end of the first year, then what this implies is that I have given that 15,000 as loan to you at the end of first year. So I have given 1 lakh to you at the end of at the start of the first year, and at the end of second year, I gave another 15,000 as loan to you. Okay, and at the end of the third year, at the end of the second year, the same thing. Whatever the interest is calculated at the end of second year, the whole interest is said to be given to you as a loan again to you. Now this is what happens in the compound interest. So all the interest will be said to be given to the person as a loan again. Now compound annual growth rate. Now what this means is that, say for example, I have started a business. In that business, I invested some 1 lakh rupees. Okay. And at the end of the third year, I sold that business to some other person for, say for example, 5 lakh rupees. Okay. I started a business for 1 lakh and until the third year, I didn't take anything from that business. Okay. I did not draw any profits from there. I just reinvested everything. Say for example, at the end of first year, I got some profit, for some 2 lakh profit. Okay, I didn't take anything from that profit. I just reinvested the whole thing in the business. Like that, I did that for 3 years. And at the end of the third year, I just sold the whole business to some other person for 5 lakhs. Okay. So at the end of the fifth year, I got 5 lakhs. At the start of the first year, I invested 1 lakh. So for 3 years, what is my rate of return? How much did I earn? Now at the end of the third year, the total amount I received is 5 lakhs, right? So total profit is 4 lakhs. So my total rate of return is 400%. Now I need to calculate how much return I earned each year. Now the rate at which the business has grown each year is known as an compound annual growth rate, short form CAGR. So in here, I have reinvested all my profits into the business. At the end of some period, I need to be able to calculate my annual growth rate. Okay. Say for example, today my business is worth 1 lakh. And down the line, at the end of 7th year, my business is worth some 20 lakhs. The whole of 7 years, I have not taken any profits from the business. I have reinvested all the profits, whatever I got from the business, reinvested into the business only. So from this, we can say that I got a total of 1900% of returns. Okay. Now I need to find out how much percentage of growth the business has seen for the whole of 7 years. Okay. I've been reinvesting the amount in the business, right? So I need to know compound annual growth rate for each year, how much the business has been growing to get a percentage of 1900. So compound annual growth rate can be calculated using this formula. Okay, where CAGR is equal to VTN divided by VT0 whole power 1 by Tn minus T0 minus 1, where Vtn is equal to value at the beginning and Vt0 is the value at the beginning, Vtn is the value at the end. Okay, Tn is the end period, T0 is the start period. Now to calculate CAGR, we use this formula. Does this make any sense to you? By seeing this, do you think, have you ever seen this formula until now? Maybe if you read about this formula, okay, fine, no problem. You would have seen it. But from seeing my videos, from seeing this video also, can you recognize this formula? No, I don't think so. In the previous video, that is expected rate of return versus discount rate video, we derived a formula. Present value into 1 plus r power n is equal to future value. Okay. From this formula, if we rewrite this formula, then we can get this formula. Pause the video and try to convert this formula into this one. See what is meant by CAGR. The assumptions in the CAGR is that first assumption is I've invested some money at the start of the period. Okay, that is my present value, and in that business I will be keep on reinvesting my profits into the same business. I will not take anything home with me. This formula is used in compound interest, right? In compound interest we use this formula, and also in expected return also we use this formula, right? If you remember the previous video, there we explored very clearly how this formula came about. Okay, from this we know that we know where to use this formula. What each and every term represents here, it represents that at the end of the period I will not be taking anything with me. I will reinvest the returns into the business. Okay, if it is a business, I will reinvest the profit into the business. If it is a loan, I will give the interest to the same person as a loan again. So it will be added to the principal amount. Okay, if it is business, the whole amount will be added to the capital amount. So like this, the returns will be keep on reinvested into the business, and then we will get the future value. So CAGR represents the rate, the common rate, the rate at which value today has grown to the future value. Okay, so what does this formula represent? If we do this calculation, I mean PV into 1 plus r power n, then we will get a future value. So here r is nothing but CAGR. If we keep this r in this side and send all the remaining terms to the right hand side, what happens is that 1 plus r power n is equal to future value divided by PV. Now we need to send this power to that side. When we are sending a power to the other side of the equation, then that power will be inversed. Okay, like this. 1 plus r is equal to future value divided by present value power 1 by n. Okay, like say for example, if it is for 2 years, then what happens? 1 plus r square is equal to future value divided by present value. 1 plus r is equal to square root of future value by present value. Square root can also be written as future value divided by present value power 1 by 2. Okay, if it is for 3 years, then what happens? Power 1 by 3. Like this, power 1 by n. Okay, so if we send this r, if we send this 1 to the other side, then r will be future value divided by present value power 1 by n minus 1. Okay, so this whole thing and this whole thing, they are both the same thing. Okay, let's see how. So here r represents CAGR. Okay, here what does this VTN represent? It represents the future value of the business, at the end of the business. So at the end of the business, future value is nothing but the end value of the business. Okay, whatever it may be, whether it is business or whether it is loan, whatever it may be, it represents the future value. Here also, here we are only talking about, in CAGR we are only talking about business, but this formula talks about everything. Now, so these both represent the same thing. Now, VT0 represent the value at the start of the business. Here, present value represents the value at the start of the value at the start of the period. I mean, whether you are investing or whether you are giving as a loan, whatever it may be, that will be my present value. It can represent principal or it can represent initial capital also. Here, it is representing capital. Okay, 1 by n. See, Tn minus T0 is nothing but Tn is the end of the period. Say for example, some 7th year. Okay, T0 is nothing but 0 year, at 0, at the start of the point, right? So 7 minus 0 will be 7. 1 by 7. So for the 7th year, here also the term n will be 7 only. And minus 1, minus 1. Minus 1, minus 1. From this we can say that however complicated it may seem, however complicated the equation may seem, if we understand the terms, if we understand the meaning, the true meaning of the terms, then we can use those terms however we want. We will be able to know when to use those terms and how to use those terms and what terms to use in what situation, and also why to use them, why we are using them. Okay, here in the whole video I used only one equation, that is PV into 1 plus R power n is equal to future value. This is the most important equation in the whole of financial management. In the previous video also I told you that almost each and every problem in the financial management can be explained with this one equation. If you know this equation, if you know each and every term in this equation, if you know the true meaning of the terms in this equation, you will be able to understand and solve problems in every concept in financial management. What I'm saying is, when you are learning something for the first time, then try to understand definition of each and every term in the concept. If you know pure definition, then you will be able to use them properly. We got this formula, right? Let's just do one example with this formula and get an answer for CAGR. Okay, in the previous example what I took, say for example, today I have 1 lakh with me. Okay, after 3 years it has become 3 lakhs. So at what rate 1 lakh has become 3 lakhs annually? At what rate it has grown to 3 lakhs? We need to calculate that. So this is my future value, this is my present value. Number of years is 3. So if we substitute all these values, what happens is that 3 lakhs divided by 1 lakh power 1 by 3 minus 1. Now here 3 lakhs divided by 1 lakh will be 3 power 1 by 3 minus 1. 1 by 3 can be written as 3 power 0.33 minus 1. So if we solve this, then we will be able to get the answer R. Okay, how do we solve this? If you are a math student, then you know how to do this. You can use logarithms. You can use logarithms and solve the equation. If you don't know logarithms, then you can calculate this value with calculator. Okay, you can use calculator to find the value for this. Okay, now 3 is the base, right? Now you need to square root this 3 12 times. Okay, 3 in calculator, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, if you do the square root for 12 times, for 3 it will become 1.000026825. Okay, now what you need to do is you will get an answer, and from that answer you need to minus 1. Okay, minus 1, you will get an answer from this step. Then you need to multiply the power. This is my power, right? 0.33. So I need to multiply 0.33333333. Okay, then I will get 0.0000894178. Okay, and the answer I will get an answer, right? From to that answer I need to plus 1. I need to do plus 1. Answer into is equal to, I need to press into is equal to 12 times. Okay, into is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I will get an answer of 1.4423 minus 1. That is equal to R will be 44.23%. This is my compound annual growth rate. Okay, this is how you calculate compound annual growth rate. See, here you are using only one formula, that is present value into 1 plus R power n is equal to future value. With this formula we got simple interest, compound interest, CAGR, and there are almost 90% of the formulas in financial management are rooted with this one equation. Okay, so I implore you, I suggest you, I recommend you, I do whatever to watch the video on discount rate versus expected rate of return. That video is the most important video you will ever see in financial management. If you properly understand each and every term in that video, and in this example, in this, if you understand the meaning of each and every term in this equation, you will be able to understand each and every concept in financial management.